Good morning, class. Welcome to our science subject. I'm excited to be covering this new book with you, Weather and Climate. We're going to be covering or refreshing some of the things that we've learned previously, but we're also going to be learning some new things. And this is what we're going to be starting with for the first little bit of third quarter, and then we'll be moving on to energy transfer and transformation after. So to start, let's build a little bit of a background and a foundation for what we're going to be covering. So first, let's talk about our objectives, things that I want you to be learning this year, all right? So if we look right here, we can see our objectives. We want to be able to understand what causes weather, explore weather factors related to air, explore weather factors related to the water cycle, things that we talked about. We talked about the weather cycle last year. Discuss 3 types of severe weather, so learn what severe means and what severe weather is. Describe methods of predicting weather, discuss weather instruments, understand air masses and fronts, interpret information displayed on weather maps. So when a weather map is pulled up, you'll be able to understand what's going on. Explain how climate and weather are different, so they're not the same thing, and then discuss factors that affect climate. Okay, so I know that's kind of a lot, but as we go through these lessons for the next few weeks, I know you'll be able to understand these objectives and be able to be successful during this section. Let's read a little bit of the science background right here. If you read and follow along with me, it starts with, weather is the state of the atmosphere at a given place and time. All weather is caused by energy from the sun. The sun heats earth, causing water to evaporate and warm air to rise. When warm, moist air rises, cooler air rushes in to take its place. The uneven heating and cooling of Earth causes the air and the atmosphere to circulate. This continuous circulation of warm and cool air brings changes to weather. And then we're going to skip these 2 paragraphs. You can pause the video and read them if you want. We're going to go down to climate. Climate is different from weather. Climate is the average weather pattern in an area over a long period of time. The 2 main characteristics of a region's climate are in its average temperature and average precipitation. Okay, so that is going to be our foundation to what we're going to be learning this time in weather and climate. Some of you guys are already getting ahead, which is awesome, but please, 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 take your time, use your own words, use critical thinking to explain the answers to the big questions. That will better help you be prepared for the test and be able to better understand this information, which will help you now and later in class, but then also understanding whether, and in life, whether you're going to be traveling, to understand what is going to be coming, okay? So don't copy and paste. Please expound and describe your answers instead of just one-word answers, and that will give you full credit, okay? So let's jump into weather and climate. And we kind of just got a brief introduction that weather and climate are different, and we're going to dive deeper into that. And as always, a good place to start when you get a new book is to look at the front page and reading the table of contents. And we don't have the front page right here on the PDF, but you should have got a copy of this book, and we'll have a front page to it as a hard copy. So we look through the table of contents, we can see that this red is kind of the 3 sections that we're covering. What is weather? How is weather how is weather measured and predicted? And what is climate? So those are our 3 sections. And then we have our little subsections, which you'll have checkpoints for each of these sections to answer the big question or to answer a discussion post about these checkpoints. And then we have the glossary, which will help you with your vocabulary, which you should have done yesterday if you're watching this video on Tuesday. And then just to stay on track, you can do it kind of however you want, but if you follow the schedule on Canvas, that will help you be on top of things and not fall behind, all right? Okay, and then build reading skills. This is what we just talked about. Preview the book, look at the front cover, look at the title page, look through the book to kind of see the overarching themes that you're going to be covering throughout the book. Okay, and then let's get into our first section. What is weather? Let's make a connection. Thick fog often develops under the Golden Gate Bridge, which is this right here in San Francisco, California. And I was born in California. Fog is actually a type of cloud. How do you suppose fog forms? All right. How do you suppose all this fog or this cloud forms right here? What do you think? Do you think it's with hot air rising or falling, cool air rising or falling, moisture? What do you think? Well, as we read through this section, we should be able to answer that question. So during this section, we'll read what causes weather, what factors related to air, weather factors related to air, weather factors related to the water cycle, and then 3 types of severe weather. And those should be your checkpoints as well. All right, diving in. And please follow along with me. If you need to pause this video or pause your reading, you can do so. Get up, move around, stretch, get some water, get a snack, and then come back. All right, let's stay focused. This lesson should not be too long, and it should be enjoyable. All right, about weather. Weather, and you can see that this is bold, which is your first vocabulary words. Remember, use the glossary in the back of your book to fill out the vocabulary words. Weather is the condition of the atmosphere or the air that surrounds Earth at a certain place and time. So what is the weather today? Well, I woke up around 6 and went to go work out with my brother, and it was very cold. So the weather was cold. It was frosty. My windshield was all covered in ice, and I had to scrape it off. And so that was the weather at this certain time and place. So Earth's atmosphere extends hundreds of kilometers into space and is divided into different layers. We talked about this last year. Most of Earth's weather occurs in the troposphere, the layer closest to the Earth's surface. All weather is caused by energy from the sun. The sun warms the land and water on Earth's surface. The heat from the surface then warms the air above it. However, the sun heats Earth's surface unevenly. Some areas receive more heat than others. The amount of heating depends mostly on the angle at which the sun's rays hit an area. Places near the equator are warmest because the sun is high in the sky and the sunlight hits the earth directly. Places near the poles, so either the North Pole or South Pole, are coldest because the sun is low in the sky and sunlight hits the earth at a slant, so coming in at an angle instead of directly. This uneven heating causes air to move and weather to change. When scientists describe the weather, they consider 6 main factors or conditions: air temperature, the amount of moisture in the air pressure, wind, cloud cover, and rain or snow. In this section, you will read about these 6 factors and how they are related. Your first checkpoint is define weather and explain what causes weather. We just barely covered that in those few paragraphs. So let's look at these 2 pictures and read the caption. Cloud cover, or the amount and type of clouds in the sky, is one of 6 main weather factors. So cloud cover is one of the 6 main weather factors. Let's read it. Look at this picture of these kids playing soccer. Weather, or the condition of the atmosphere at a given place and time, affects our daily lives in many ways. For example, an unexpected rain shower may result in a canceled soccer game. I bet some of you guys have experienced that. I know I have. Okay, so now it's going to cover the 6 main factors. All right, so weather and air. 4 of the 6 main factors that make up weather are properties of air. So 4 out of the 6 are properties of air. A property is a characteristic that can be observed with the senses or measured. So properties are things that we can measure, right? So the humidity we can measure, the air temperature, we can measure that. How it's really cold right now, so we can measure that. So those are examples of properties. Our first property, or factor of weather, is air temperature. Temperature is a measure of how hot or cold something is. As heat energy is transferred from Earth's surface to the air above it, air temperature increases. Air is composed of tiny gas particles that are in constant motion. The increased energy causes the particles to move faster and spread farther apart. The higher the temperature, the faster of the motion of the particle. So if the warmer it is, the faster these particles are moving, okay? So if it's cold, do you think the particles will move even faster, or do you think they'll start to move slow? Let's find out, huh? I bet it's the opposite. Air temperature changes often. For example, it typically varies with the time of day. Days are usually warmer than nights because Earth receives energy from sunlight during the day, but not at night. Air temperature may also change with the seasons. In any given place, summers are usually warmer than winters because there are more hours of daylight and the sun's rays strike that part of the Earth more directly. So right now we're in the winter months. We don't have as much sunlight as we do during the summer months, and that is one of the reasons why it is colder, because the sun is not hitting us directly for a longer period of time. Humidity. Humidity is a measure of how much moisture is in the air. Air is a mixture of many gases, including water vapor, which is water in the form of a gas. And I and my wife and my family, we've kind of come from more humid climates. We've spent, especially me and my wife was born in Virginia. I spent the last 7 years there. A lot more humidity and moisture in the air. And we come here to New Mexico where it's drier and our hands are starting to crack and our bodies just feel dry because we feel like the water is getting sucked from us. So we like humidity. Maybe you guys like the dry weather. You can let me know in the comments what you prefer. So the amount of water vapor or moisture in the air depends on many factors, including temperature. The warmer the temperature, the higher the humidity can be. On a hot, humid day, the air feels damp and sticky because it contains so much moisture. Okay, let's pause and look at these cool pictures. We got 3 of them right here. We got this picture of the sunset, and what does this caption say? After sunset, the land, water, and air no longer receive heat from the sun, energy from the sun. As a result, nighttime temperatures are generally cooler than daytime temperatures, right? The higher the temperature, the higher the humidity can be. When the weather is hot and humid, the air feels sticky. And then this looks like we're about to get into this, but this will be a little glimpse of what we're about to read. Air pressure decreases with elevation above sea level. We learned about this in our first section during our first quarter with maps and mountains. The higher we get above sea level, that's the higher our elevation is. And so we're in pretty high elevation right now. I think we're like over 5,000 feet above sea level here in Gallup. And so our air is a little bit thinner here than it would be if we were in Florida right next to the coast. Okay, so as the mountain climber hikes higher, the air pressure around him is lower. The air is thinner, making it harder to breathe. All right, so that was a little glimpse of what we're about to read here in air pressure. So air pressure, although air is invisible, it takes up space and has weight. Weight is the force of gravity pulling down on objects in the case of the gas particles that make up air. The weight of the air around Earth pressing down on Earth's surface is called air pressure. So the weight of the air pushing down on Earth's surface is called air pressure. Air pressure is affected by elevation or distance above sea level. The higher the elevation, the lower, so not as much air pressure there is. This is because the higher you are, the less air there is pressing down on you from above. That makes sense? So when we're down on if this is sea level, when we're down on the sea level, we have all this air above us pushing down. But as we move up above sea level, we have less air kind of covering us. Less air above us. There's more air below us, not pushing down on us. Air pressure also is affected by air temperature. Cold air tends to have higher air pressure than warm air because it weighs more. When air is cold, its tiny gas particles are closer together, making cold air denser and heavier. Cold, dense air sinks and applies more downward pressure on Earth's surface. The particles in warm air are farther apart. As air warms, it becomes lighter and less dense. Warm, light air is pushed upward and therefore does not press down as hard on Earth. Areas of high pressure form where cold air sinks, and areas of low pressure form where warm air rises. Okay, so let's look at these two pictures showing cold air and warm air. And let's reiterate what we just read. Cold air usually has higher air pressure than warm air. This is because cold air is heavier and presses down on Earth's surface with more force than warm air. So out of these pictures, left or right, which one would have dense, heavier air? So which one would feel heavier? The left picture, the cold, or the right picture, the warm air? Well, let me know down in the comments below which one you think. Okay, so wind. Differences in air temperature and air pressure cause air to move. Air generally moves from areas of higher air pressure to areas of lower air pressure. Cool air has higher pressure than warm air. So air moves from cooler to warmer places. This air in motion is wind. Some winds are local winds, which affect weather only in a small region. Sea breezes and land breezes are local winds. So if we were on, let's say we went down to the coast, we went to California, went to the beach, the air coming in, that would be a sea breeze, right? Moving from colder to warmer areas. So right here, recall that the sun's energy heats Earth's land and water, and the heat is transferred to the air. However, land heats up and cools down faster than water does. During the day, land warms up more quickly than water. Warmer air over the land is pushed by cooler air moving in from over the water. This creates a sea breeze. At night, land cools down more quickly than water. Warmer air over the water is pushed up by cooler air moving out from over the land. This creates a land breeze. Okay, so let's look at these two pictures right here. So during the day, the land heats quicker than the water. So we have cool air coming in over the water to the land, and this creates a sea breeze. And then at night, the land gets cooler faster than the water. The water's been heating up all day, and it takes longer for it to get cool. So the cooler air from the land pushes out from the land to the sea, and the warm air is coming in from the sea. This creates a land breeze. All right, so in contrast to local winds, prevailing winds from a pattern of moving air over large parts of Earth. These global winds are caused by the uneven heating of large areas of Earth's surface and by Earth's rotation or spin. Prevailing winds blow from the same general direction. In the United States, winds called the prevailing westerlies blow from west to east. Okay, so from like California to Virginia. Okay, and then here are what are 4 characteristics or properties of air are important weather factors, right? So remember, 4 out of the 6 main factors are characteristics or properties. Things that can be measured is a characteristic or a property. Okay, so that was your checkpoint. And then now let's jump into our next section, weather in the water cycle. And let's pause really quick. I think we just have 2 more sections, and then we're done for today. Okay, so you guys are doing really good. Yep, 2 more sections. We have weather in the water cycle, and then severe weather. Okay, the last 2 weather factors, clouds and rain, are part of the water cycle. The movement of water from Earth's surface to the atmosphere and back again. Water changes state from liquid to gas to liquid again during the water cycle. These changes occur as water gains and loses heat energy from the sun. As the sun warms water on Earth's surface, some of the water takes in enough energy to change to gas in a process called evaporation. So right here, water from the earth with the heat from the sun changes from liquid to gas and starts to evaporate. Water evaporates from Earth's oceans, lakes, and rivers, as well as from soil and plants. The gas, water vapor, that's what it's called, the gas that is formed from the evaporation, water vapor, becomes part of the air. So it's up here now. Warm air rises into the atmosphere and begins to cool. Eventually, the water vapor, which is the gas, in the air becomes so cool that it changes from a gas back to liquid water in a process called condensation. So the water heats up, evaporates, comes up into the atmosphere, it starts to cool down and starts to condensate. Water vapor condenses on dust particles in the air, forming water droplets so tiny they stay suspended in the air. Billions of these droplets cluster together into clouds. So clouds are billions of water droplets, right? It's very light, so they stay in the atmosphere, right? So they're not falling to the earth because they're not heavy enough. But clouds are made up of water droplets. So within clouds, the droplets combine and become large and heavy enough to fall back to the earth as rain or snow. Any form of water falling from the atmosphere to earth is called precipitation. So any form of water. So that could be rain, that could also be snow or hail, right? Those are all ways that these clouds precipitate, or this water precipitates. So some precipitation seeps into the ground and becomes groundwater. This right here. Most precipitation flows along Earth's surface as runoff. So coming down the surface, probably into lakes or rivers or oceans. And in time, some of this surface water evaporates and the water cycle continues. All right, pretty cool, huh? So going back to this picture, right? How did this cloud form? What do you think? Put down in the comments below. Now we just talked about the water cycle. Okay, so clouds. All clouds are the result of water vapor condensing in cool air. But not all clouds look the same or signal the same type of weather. Clouds have different shapes, sizes, and colors depending on condition in which they form. Flat, layered clouds called stratus clouds. Right here, this is a picture of stratus clouds. Spread like a blanket across the sky, sometimes making the whole sky look gray. Stratus clouds form close to Earth's surface and usually indicate that light rain or snow is on the way. White, puffy clouds that appear to rise from flat bases are called cumulus clouds. Here's a picture of cumulus clouds. That makes me think of the movie Elf, how the snowman talks about how he was once a cumulus cloud. They are sometimes called fair weather clouds because they are common on bright summer afternoons. However, very tall, dark cumulus clouds may signal that a thunderstorm is coming. Okay, clouds that look like wispy streaks or feathers are cirrus clouds. Cirrus clouds are made of tiny ice crystals because they form at very high altitudes where the air is extremely cold. Thin cirrus clouds are usually a sign of cool, fair weather. So these clouds right here, ice crystals in the air, pretty cool, huh? Tiny ice crystals. Wonder if we'll have any of those today. Many clouds are variations of these three main types. Many clouds are variations of these three main types. Fog is a stratus-like cloud. So right here, that spreads like a blanket that develops at ground level. The tall, dark cumulus clouds that bring thunderstorms are called cumulonimbus clouds. Maybe that's what the snowman talks about, how he came from a cumulonimbus cloud. I can't remember. Anyways, a cloud that brings rain usually has nimbus, meaning rain, as part of its name. Yeah, so it's probably a cumulonimbus cloud. Cool, huh? So a fog is like a stratus cloud, but forms close to the Earth's surface. Precipitation. Remember that precipitation occurs when water droplets or ice crystals in clouds become heavy enough to fall. Rain is liquid precipitation, while sleet, hail, and snow are frozen or solid precipitation. The form that precipitation takes depends on the air temperature. Rain falls in the temperature of the air between the clouds and Earth is above 0 degrees Celsius or 32 degrees Fahrenheit. Rain is the most common type of precipitation on Earth. If rain falls through a layer of air that is cooler than 0 degrees Celsius or 32 degrees Fahrenheit, the raindrops freeze, forming bits of solid ice called sleet. Rain also can freeze when it hits very cold surfaces at ground level. This freezing rain can break trees and power lines and cover roads and sidewalks with a slippery glaze. So that reminds me, I was in Pennsylvania for 2 years for a church mission, and we were driving to go to church, and the parking lot looked normal, but it was actually covered with freezing rain. It like you couldn't tell that it had ice on it because it was like a perfect glass layer of ice. And so when we went to go pull into our parking spot, we started to slide and we slid through like 4 parking spots. Luckily, no one was there, no one got hurt, but that was pretty crazy experiencing freezing rain. So like it froze when it hit the ground. All right, so sometimes frozen raindrops pass through warm air and become coated with liquid water. Wind then carries them back up into cooler air, and then the coating of liquid water freezes. This up and down process can occur over and over, creating larger chunks of ice called hail. Ice crystals form in some clouds. If the air between the clouds and the earth is cooler than 32 degrees Fahrenheit, these crystals or flakes reach the ground without melting. This type of precipitation is snow, and that is probably my favorite type of precipitation. Okay, then here is your checkpoint. How are clouds and precipitation produced during the water cycle? You probably have to refer to page 8 and 9 to help you out with that, okay? This will also help you, this little table. Okay, let's move on to our last section. Severe weather. Storms can sometimes bring severe weather, which is weather that may be dangerous or may cause damage. Thunderstorms, tornadoes, and hurricanes are examples of severe weather. And so we have a checkpoint question about this, and please describe your answer to the 3 types of severe weather, okay? Don't just put what they are, describe what they are, like what they do, how they're formed. Just go in depth about each of the severe weather, okay? So most communities have warning systems and safety guidelines to help protect people during severe weather. Paying attention to weather warnings and having a family emergency plan can help you stay safe. That is why it's important to talk with your teacher, me, and your family about weather safety and to know weather safety rules. Okay. Thunderstorms. Thunderstorms, the most common type of severe weather, occur when hot, humid air rises very quickly and then cools. The upward rush of air causes large, dark cumulonimbus clouds to form. A thunderstorm may result, producing strong winds, heavy rain, lightning, thunder, and sometimes hail. Here's a picture of lightning. That's pretty wild, pretty cool. Most thunderstorm damage is caused either by flash floods from the sudden downpours or by lightning strikes. Lightning is a bright, powerful flash of light caused by moving electrical charges. Inside storm clouds, electrical charges build up. Lightning occurs when these charges suddenly jump within a cloud, between clouds, or from a cloud to the ground. Lightning heats the air around it to an extremely high temperature. Thunder is the sound of air rapidly expanding because of the huge and sudden temperature change. Okay, pretty cool. Or maybe Thor is just in that cloud making noise, right? The god of thunder. There's a picture of a tornado. That is pretty wild. Whew. That's crazy. Okay, so tornadoes. Weather conditions that cause severe thunderstorms can sometimes produce tornadoes. In fact, the name tornado comes from tronada, the Spanish word for thunderstorm. Recall that thunderstorms form when hot, humid air rises and cools, creating towering thunderclouds. A tornado is a violent, spinning funnel of air that extends from the bottom of the thundercloud to the ground. Tornadoes are sometimes called twisters because of their twisting motion. Tornado winds are extremely strong, with spiraling winds sometimes reaching up to 500 kilometers, which is about 310 miles per hour. Tornadoes also travel very quickly along the ground at speeds of up to 115 kilometers or 70 miles per hour. Most tornadoes touch down on the ground for only a few minutes and travel along a very narrow path. However, a tornado's powerful winds can cause great destruction. Here's a picture of destruction. This tornado lifted these trees out of, like, lifted up these trees from their roots or uprooted them. So tornadoes are more common in the United States than anywhere else in the world. Every year, about 1,000 tornadoes occur in the United States, mostly in the Midwest and the South. Tornadoes usually form in spring and early summer, maybe when the air is changing, right? Cool air is leaving and warm air is coming in. All right, and then this is our last severe weather that we're going to learn about, hurricanes. The largest storms on Earth are hurricanes. A hurricane is a huge, powerful storm that produces extremely strong winds and heavy rain over a large area. It begins when a large body of air with very low pressure forms over tropical ocean water. The low pressure area gains moisture and energy from the warm ocean waters. Winds increase in speed and begin to blow in a circular pattern, creating a tropical storm. When the winds reach 119 kilometers, or about 74 miles per hour, the storm is classified as a hurricane. The peak season for hurricanes is between August and October. Hurricane winds spin around a calm area called the eye. So let's get this picture right here. It's pointing at the eye, and then the hurricane, the winds are spinning around that eye. So the eye, where there is little or no rain and only gentle wind. The swirling storm can travel long distances over warm ocean water. Once a hurricane moves over land, it begins to weaken. Even so, hurricanes can cause terrible damage, especially along coastlines. They create pounding ocean waves that can batter shorelines and cause flooding. Sometimes, storm surges can wash away beaches and roads and destroy buildings. A storm surge is a bulge of ocean water pushed toward shore by hurricane winds. That's pretty wild. Okay, here's your last checkpoint. Describe 3 types of severe weather. So don't just name the 3 types. Describe the 3 types, please. And that's how you can get full credit, is by describing the 3 types that we just learned about. And then don't forget your apply science concept. Okay. And then that is our lesson for today. Glad to be with you guys today. If you have any questions, please reach out to me and I will get back to you. And I hope you have a good rest of the day, and I'll see you guys in the next video lesson. See ya.